4. Today I remember. Okay, okay. You see the whiteboard, no? Okay, today we study in detail, solution for the linear system of equations. I don't care how many equations. I don't care how many unknown. A big system. Of course, we're using software. They want to explain in detail how you using that and how we can analyze. It's the most important. Okay. Let me introduce theoretical part. Look. We have 3 cases. Number 1 case is when the number of equations is equal the number of unknown. This is the most common typical, right? 3 equations, 3 unknown, x, y, z. And in this case, the name of this system is called determinant. It's determinant because we have exactly the same amount of the equation and unknown. For example, 3 equation, 3 unknown. 2 equation, 2 unknown. 25 equation, 25 unknown. Determinant. And determinant we study in the last chapter that we have 3 possibilities. One solution, a unique solution, infinity many solution, and no solution. You know that, right? Okay, but now we study more generalized idea in which, for example, you have the number of equation is less than the number of this is called under determinant because we lack information. Because to be completely determinant, we have the same amount of equation. In this case, suppose that we have only 2 equations, 2, and 3 unknown or 4 unknown is under determinant. In this case, well, in this case, the most important thing you need to understand is never we have one solution like that. This possibility, no, never. We have maybe infinity many solution or no solution. Remember, for example, suppose example to understand this idea, but this is general concept. Suppose we have 2 equations and we have 3 unknown. 2 equations. Remember, in 3 unknown, 3D, each equation represents plane. And suppose we have only 2 planes. So the only possibility of the 2 planes is that the plane touch, cross it, touch it. But touch it, form one line, never a point, or the plane are parallel, never touch, no solution, or infinity many solutions. Never we can determine one solution. It's impossible. And number 3, the opposite situation is we have a number of equations is greater than the number of unknown. So in this case, we have too much information. But too much information is good or is bad? Always is good, right? Entonces this is called over-determined. Entonces in this case, we have, for example, suppose we have to understand this situation. Suppose we have 4 equations and just 2 unknown. To understand much better the geometric interpretation. 2 unknown is the classical x and y, no? But we have 4 equations. Okay, entonces suppose geometrically speaking, look at that. X, y. Suppose the first equation, we have 4 equations in one line like that. Bam. The second equation is another line. Bam. The third equation is another line. And passing by it's a coincidence que passe for the same point. And the 4 equations, the last equation may be pass or maybe no pass. Suppose this situation or suppose this situation. Entonces es possible, technically it's possible, one solution. When the 4 equations have a common point, but it's very, very hard. It happens. So when you see, oh, you have 5 equations in 2D, look like we have no solution. But I try to solve it, no? Okay, maybe yes. Of course, infinity many solution is possible and no solution is possible. Suppose the lines are totally parallel. Pam, 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 pam. 4 equations, 4 lines. Never meet, never cross, no solution. Do you understand very well? Any question about this idea? Today we are solving, I bring several examples to illustrate very well this idea. Okay? But remember, I sent to you one email with the link connected with the GeoGebra, and the GeoGebra, you open, you have specifically the example we covered today. However, no, I want to do one by one again in front of you. Okay, let me explain. GeoGebra, my recommendation, as I said at the beginning, the student connecting late, you need to create account. Create account. Similar to account that you create in Desmo, but now in GeoGebra. You using just username, password, your credential, and that's it. And you practice. Okay, then in GeoGebra, when you open GeoGebra, we have open now, you go to the view. In view, you using three windows, no? 3 pages. The first one is algebra. Actually, we have 2 algebra. Just algebra and algebra 2. No algebra. The common algebra. CAS. CAS means computer assistant software. It's the most important tool that we have in GeoGebra. And one is a spreadsheet. A spreadsheet look like similar to the spreadsheet. And the spreadsheet, we use the editor of the matrix. Now you type in the number, no, the element, the number inside the matrix. By the way, this number is called in the language of matrix entry. I don't know why. Okay, so you type in the element. Let's call element, and you create the matrix automatically. A spreadsheet transfer to the algebra of the matrix, and using CAS, you solve the matrix. In this case, we're using the famous function reduced row echelon 4. I suppose que es the name. But okay, when you start typing R, capital R, E, T, go ahead.
Sorry to interrupt you, Professor. Ernesto Cabrera says he can't get into the class. He just wanted me to let you know. I think 1-2's having an issue.
Why not? Ernesto Cabeza?
Yeah,
I suppose I send the link like
I know.
Everyone.
I know, Professor. He's just telling me that he can't get in for some reason.
Okay. If you want to help to him, it's your friend, no? Okay. So you type in capital R, E, D, U. Automatically you see the name. So you inside you put the matrix N1 or matrix, the name of the matrix, name. Press enter, and then the echelon is this form in which the matrix contains a pivot 0, 0, 0, the second pivot 0, 0, 1. In the right hand side, okay, by the way, the software don't write this line. You have numbers, suppose 2, 3, 4. So you can infer, okay, the first equation is x equal 2, y equal 3, and z equal 4. Okay? Here, any question? Let's go to Desmos. To Desmos, no, to GeoGebra. Okay, GeoGebra now. May share screen. GeoGebra. Not necessarily the distribution of the window in your GeoGebra. I have two computers. This computer you see GeoGebra now? Do you see it? Yes or no?
Yes, sir, I see it.
Yes, sir, we see it.
I have two computers. And the computer you see is a laptop. Because when I have Skype installed, the distribution is, look, the distribution is the first window and the extremely left is algebra. The middle one is CAS, and the extremely right is obvious it's a spreadsheet, no? Because you see the grill. Okay. Entonces, how you set out that? Not necessarily do it now, please. I want to recording today whole lectures. When you watching again, you try to do by yourself. Don't watch it on this because it's confusing. I click wrong, professor. No. You pay attention, try to pay attention, and let's do it together. Okay, you click here in the tree line, and I don't know exactly what is the technical name of the tree line. Some people call the Herbert, the burger. Okay, in the burger you click and you select view. In the view, you can see you select the window that you want: algebra, CAS, and spreadsheet. I don't want graphic. I don't want graphic 2. No algebra 2, graphic and graphic 2, and graphic 3 dimension, que es cálculo 3. Okay, pero no worry. You click outside. Okay, so let's do the first example I bring today. Okay, sorry guys, I want to come back to the whiteboard to write the system, no? Whiteboard now. Okay, let me see. Whiteboard. Do you see whiteboard now or no? Or no? No? No whiteboard?
Not yet.
Okay. Let me erase. Boom. Stop. Now, whiteboard. Yes?
It's there now, sir.
Okay, it's there now. Okay, the first example is example 1. X minus y equal 6. Equation 1. 2x minus 3z equal 16. Equation 2. Plus c equal 4. Equation 3. Ooh, 3 equations. So we have 3 equations. And how many unknown we have in that problem?
3.
3. So what is the name of this system? Is determined, is underdetermined, or overdetermined?
Determined.
Exactly. I have no idea if we have one solution, infinity many solutions, or one solution, but it's possible. So the first job is write the system in matrix language. Okay, I open the bracket like that. Here I copy one column for the X, one column for the Y, one column for the Z. I separate by the line and the paper and the computer. No, I don't know why. On the right-hand side is the number in the right-hand side. So say 1, -1, 0, because C is missing and the first equation 6. This is my first row, que es the representation in matrix form of my first equation. The second equation is 2, y is missing, -3, 16. And the last equation have no x, 0x, 2y, 1z equal 4. And by the way, is 3 by 4 because this matrix contains three rows and 4 columns, no? And 3 rows because it's 3 equations. And always the first dimension represents the number of rows, represent the number of equations. Okay, now with this information, I am ready to start your GeoGebra part. Let me see. Okay, switching. GeoGebra. Switching. Switch GeoGebra. Do you see GeoGebra now?
Yes, sir.
I do,
Super.
Professor, but I have a little issue. I was trying to put the 3 inputs, the CAC, the geometry, and I saw you did it, but for some reason it's not working the same for me. Can you go over that just one more time? Because you want 3 inputs, correct? You want geometry, cal, and what else?
Spreadsheet.
What is
Look,
it?
let me show you. Let me show you, Mister. Look.
Yes, sir. Okay.
You click here.
Right there.
Click here.
Okay.
You click here. Algebra.
Algebra,
CAS.
and spreadsheet. Algebra, CAS, and spreadsheet.
And you organize in the way you want. I explained that, for example, in my laptop, I organize in the way you see now. But in the other computer, I have completely different. No, I have completely different. Completely. Oh, don't worry. The most important is you typing in the spreadsheet the number, no? Que the number is 1. Press the key tab in your computer, -1, 0, 6. Okay, and this is my first equation. My second equation is 2, hey, noise, 0, -3, and 16. Now I click here on this cell, 0, tab, 2, tab, putting off microphone, please, and 4. Okay. I have a question. Do you follow me or you only watching my work? Either way, guys. Either way.
Both.
Both. Okay. No. Okay. I have no problem. Professor, I click wrong. No. I cannot fix it because I don't see your screen. You see my screen, but I cannot see your screen. Okay. So when you finish to edit the number inside the matrix, you select everything using the mouse selection, similar to the spreadsheet Excel. You press right click and select create. Create what? Create a matrix. Okay, automatically when you see create a matrix, boom, in the algebra you can see magically your matrix. Que as default, they assume that the name is M1. If you want to change the name, you can. You right click on the name and rename with another letter. Pero no, it's okay. It's okay. M1, M2, M3, or M4. Okay, so I go to the CAS. The CAS is the part that you perform the operations, no? In this case, reduce the row low. Reduce capital R, reduce the RED, automatically, because this is the most important function. Reduce row echelon 4. You select that, boom, and highlight the matrix part, in our case, M1. N1, no capital, it's lowercase, and present. And this is the answer. Okay, I want to interpret right now. Interpretation right now. I need to go, guys. Help me to go to the whiteboard again. Look at that. When this is the way that we are doing in the test. Look, in the test, you write the original matrix. You go to the GeoGebra and you perform the function reduce row echelon 4. This is the acronym that frequently we use in mathematical language for this function. And we get this answer. Look at that. 1, 0, 0. 0, 1, 0. 0, 0, 1. This is the famous identity matrix dimension 3. It's a matrix, a special matrix that we study in your moment in detail, in which the main diagonal is just 1, 1, 1, and the rest is 0. In the right-hand side, after the line, we have 8, 2, and 0. So you translate this idea, this mathematical object, and equation, is obvious that the first row to represent the first equation is x equal a, because x is 1, Y is missing, C is missing, no Y, no C, X equal A, Y equal 2, and C is equal 0. End the story. And we're solving the solution. In this case, we have unique solution, only one, is the triple order A, 2, 0. End the story. Any question? This is
No, sir.
fantastic. This is fantastic. This is science fiction, okay? But this is the most elementary example, okay, I bring today. You see more complicated now, and you identification, what case we are doing? We are doing overestimate, underestimate, infinity many solution. This is the challenge today, okay? I can erase the board. I can erase the board.
Yes, sir.
Yes, sir. Okay. Let me write the example 2. The example 2 is a little bit more complicated. And the example 2 we have X plus Y plus C plus W, wow, equal 4. And this is the equation 1. Minus X plus 2Y plus Z equal 0. Equation 2. 2X plus 3Y plus C minus W equal 6. Equation 3. And minus 2X plus Y minus 2C plus 2W equal negative. Okay, we have the system that contains 4 equations and 4 unknown. Yes or no? It's X, Y, Z, and W. So this is again determinate system because it's the same amount of equation and the same amount of unknown. So maybe we have one solution. Maybe I don't know. I have no idea. Maybe yes or maybe no. Okay, so let me represent a matrix 4. Remember, my recommendation is when you open the bracket, you put one column specific for the X, one column specific for the Y, one column specific for the Z, and one column specific for the W. I put a vertical line on the right-hand side. So in the paper, I organize this. And the software, no. So say 1, 1, 1, 1, 4. This is my first equation. My second one is negative 1, 2, 1, 0, no W, equals 0. The third equation is 2, 3, 1, negative 1, 6. And the other is minus 2, 1, minus 2, positive 2, negative 1. And the dimension of this matrix is 4 by 5, no? Because we have 4 columns, because we have 4 equations, and 5 columns, 1, 2, 3, 4. We have one more column than the unknown, because you have the classical 4 unknown and the extra column for the right-hand side. And this is the matrix I need to put in the GeoGebra. Okay? Everyone follow me? Easy, easy. I like this class so much to teach this because it's easy, everyone understand, and super powerful. You need, when you will be engineer, maybe you need that. Giovanni, you want to ask me something?
Yeah, I wanted to finish copying down the graph real quick, Professor. Can you just put it back on the board, please?
Yes.
Don't worry about it. I'll just look at it from here. Never mind.
Don't worry. Carajo. Wait. This is a little bit complicated. Sometimes it's missing. Sometimes no. Okay. There you go. Whiteboard now for you. Come on. You see? Copy that. Let me know when you finish. Okay, so the thing we are doing now is I go to the matrix editor. I put this number and perform the function reduce row echelon form.
Thank you, Professor.
Okay, let's do it. Switching to the GeoGebra. Super, we have a GeoGebra now. I have one space in between or two space in between the example. I type in this. The typing is 1, tab 1, tab 1, tab 1, and 4. This is my first equation. My second equation is -1, tab 2, tab tabular, no? 1 and 0. And the right hand side, 0 again. My third equation, 2 tab, 3 tab, 1 tab, -1, tab 6. And my last equation, because we have 4, -2, 1, -2 again, +2, and -1. Okay, this is my system. Well, let me see if I type it right or wrong. I have no idea. What is this? Let me see the original example. The original example is yes. Okay, super. Okay, remember I select the system, I create the matrix associated with this. GeoGebra call M2. Guys, it's important to make sure that you don't make a mistake. You make a mistake one number or you make a mistake one sign, you are doing totally different problem. And this is not good. Entonces, capital R-E-D, matrix M2. Boom. 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 Interpretation this. I want to switch it to the board now. I can or no? Okay, let me try. Share screen. Board. Carajo. Do you see the board now?
Yes, sir.
Absolutely. Well, the answer after the reduced row echelon is 1, 1, 2, 3, 0. The line 2, 0, 1, 0, 0, 1, 0, 0, 0, 0, no, coño, 1, 0, 0, and 0, 0, 0, 1, 1. Okay? The dimension stays the same because the only thing I'm doing is transformation number inside using row operation. Okay, so the conclusion is x equal to y equal 1, c is 0, and w is 1. This is the answer. You can represent like a tuple, like that. 2, 1, 0, 1. And alphabetic order X, Y, C, W. Oh, no, not alphabetic order. And this order according to this example. No alphabetic. Any question? No.
None.
Okay, super. Okay. Let me copy another example. Erase the board. The third example. The third example, you help me a little bit. Because number one, you help me to understand what is the classification of this system. And also, using GeoGebra, we determine how many solutions we have, no? Okay, it's 2x plus y minus c equal 4, equation 1. minus x plus y plus 3z equal 1. And that's it. This is my system. Okay, I give you in the test. In the test, I put this example. So immediately you recognize, wow, what is that? This is determinant, underdeterminant, overdeterminant.
Underdetermined.
Underdetermined. So when it's under, never we have one solution. We have two possibilities. We have infinity many, because remember this equation in 3D, because I have three unknown x, y, z, represent a plane, no? One plane, another plane, maybe touch, and the intersection between two planes is a line, or never touch, parallel, so we have no solution. This is the only possibility we have. Okay, no problem. However, I write in matrix language, open the bracket, 2, 1, minus 1, 4, negative 1, 1, 3, and 1. And the dimension of this matrix is 2 by 4, no? 1, 2, 3, 4 column, 1, 2 equation. Okay, let's do it. Remember, we expect maybe infinity many solution or no solution. Okay. Let me try to understand the organization of this problem. Boom, your GeoGebra now. Okay, to the space, and we continue with the third example. The third example is S2. All right, let me see. This page, okay. S2, 1, 2, 1, 2, 1, negative 1, 4. This is my first equation. My second equation is negative 1, 1, 3, and 1. Okay, there you go. This is my system. Two equations, just two equations. You select everything, create the matrix. Create matrix. Oh, I checked the number. It's okay. Everything okay. Now I solve using reduce echelon. Reduce it echelon of the matrix I call M3. Enter. Press enter. Boom. This is the answer. Wow. What the hell is that? I need to understand this. This is really fantastic. Look at that. Okay. I come back to the board. And the board, you write exactly the same you see in GeoGebra. I put the arrow R, R, E, F. Yeah, I discovered that we have 1, 0, negative 4/3, line 1. 0, 1, 5/3, and 2. Okay, this is the crucial moment to analyze the meaning of that. Let me focus. Okay, normally, the other two examples we are doing before this problem, we can see the famous identity matrix 1, 1, 1, 0, 0, 0, 0, 0, 0. In the right hand side, we have three numbers. Ba, ba, ba. This is a typical format for unique solution, one solution. But this is the new format of the infinity many solution. How do you know that? Well, you know, because this column, you know, is X column. This column is the Y column, and this is the W column, no? Entonces, this is X column, and this example, Y column and C column. Entonces, in X and Y and C, we have identity matrix. Therefore, we have no free variable. Okay, so I can see, okay, the identity matrix is here. But in this case, it's identity matrix of the dimension 2. Capital I, identity dimension 2. So the variable x and y involved inside the identity matrix correspond with the variable that is not free. It's not free variable. So the only guy can have ask me que W is the free variable. And when you have free variable, we have infinity many solutions. Entonces, how you express the infinity many solution? Easy. Look at that. In another test, in the test 2, is very, very complicated. We need to simultaneous equation. No. In algebra, in matrix, is super easy. You write, for example, the first row, que es the first equation, in matrix language is 1x minus 4 over 3w, because y is missing, look at 0, equal 1. And you solve for x. You solve for x. You isolate x like a function of w, because I know que w is the free variable, que es the independent, no? Independent variable. So x is equal 1 plus 4 over 3 w. Okay, perfect. The solution, professor? No, not yet. Now I copy the second equation. The second equation, no x, y plus 5 over 3w equal to. And you solve it again, the variable gets not free. The variable inside the identity matrix in blue color. So y equal 2 minus 5 over 3w. Okay, ready. I am ready to write the solution set. The solution set is, in this format, is the triple order, x, y, z, because I know that this solution living in 3D, x, y, this is W is C. I see is, hello, sorry, this is C. Where I come from? This is C. This is C, sorry. This is C, and this is C. I don't know, I copy W. In the original, we have no W, look at that. It's C. This is X. I'm crazy. Y and Z. Sometimes I'm crazy guy. Okay, entonces, this is not important for the most important moment. This is the most important moment now. Okay. The solution is infinity. Okay. Living in 3D, because it's X, Y, and Z, no W, such that this line, X is equal 1 plus 4 over 3Z, comma, or and, whatever you want to call it, it's the same, synonym. Y is equal to 2 minus 5 over 3Z, comma, or and, whatever you want, CS all real number, que es sinónimo to say free variable. I suppose the geometric interpretation for this system, we have two equations, and 3D is two plane, and the intersecting, yes, intersecting, we have solution. But we have no one, we have infinity, because it's a line. And the line object contains one dimension. And the dimension for the object solution is exactly the same, the amount of free variable that we have. In this case, the free variable is C. And you express the non-free variable, x and y, as a function of C, free. So C have a free, if free means it's independent variable, all real number, but x and y, no. X and y is subject to this restriction. This equation and this equation. And these together represent a line. Suppose a plane in 3D. And we have another plane in 3D. And this is common in between the plane is the equation for this. It's represent, it's possible, represent. So you take calculus 3, you see another more easy way to represent, but this is one possibility because of the intersection between two planes. Any question? No. Piece okay?
This moment, no, sir.
Okay. Okay, let's go moving on to the example 4. Okay, example 4. Example 4. Example 4 now. Okay. Let's make it zoom to see much better. Example 4 is example 4. Wow. Not good. Okay, let me change like that. This is the equation is. I have two papers. The paper for the equation and the paper for the paper for the equation and the paper for the matrix. Now, this is the paper of the equation. Example 4 is 2x plus 3y minus c equal 3. Equation 1. The second equation is x minus y minus c equal 0. Equation 3 minus x plus y plus c equal 0 again. Equation 3. And x plus y plus 3c equal 5. Equation 4. Okay, classification this system, guys. Is determinant, underdeterminant, or overdetermined?
Overdetermined.
Overdetermined, because we have too much information. I don't know. Entonces, overdetermined is very, very hard, very, very weird. Okay, we have solution. In this case, we continue working in 3D. This represents 4 planes in 3D. And we need to get 1 point common in between this. This is very, very hard. Doing by hand is crazy, but by matrix, no. Okay, let's write the matrix associated with the system immediately. The matrix is 2, example 4, 2, 3, -1, 3, 1, -1, -1 again, 0, 1, 1 no, -1, 1, 1, 0. Si I make a mistake, you let me know, guys. 1, 1, 3, and 5. And this matrix is square, no? 4 by 4. 4 row and 4 column. It's a square. 4 by 4. Now let's do it using GeoGebra, reduce the row echelon. Okay? Now surprise. Let's see what happened now. Surprise. You have no idea. Me too, I have no idea. When I solve it, I realize what's going on. Do you see GeoGebra or not yet?
It's
Not yet?
there.
Yes, there.
Yes, there.
Yeah, perfect. Okay, remember, two space, different example. The matrix is 2, 3, -1. If I make a mistake, you correct me, please. I appreciate so much. 3, 1, -1, -1 again, 0, no? -1, 1, 1, and 0. And finally, the last equation, 1, 1, 3, 5. Boom. Boom, boom, boom. Okay. Now create the matrix. Select everything, right click, create matrix. Boom, I have here. Now reduce echelon. RED. And 4 is the name, exactly the same number of the example. Example 4, matrix 4. Interpretation of this. What do you think? We have solution, infinity many solution.
Infinity many solutions.
One solution. I create this example intentionally to confuse you. Let me try. I want to copy again. Look, the matrix. Look. The answer is, The answer is, where did I copy the answer? I never copy the answer. Well, okay, no problem. The answer is 1 0 0 0 1 0, no? 0 0 1 and 0 0 0, right? In the right hand side of the line, we have 13 over 9. We have 7 over 18 and 19 over 18 and 0.
You have one solution.
Exactly. Okay, let me try to understand this. Listen to me, pay attention, please. This is the analysis that you should do. Okay, elimination process. Because actually, the thing we are doing is elimination, no? First goes Jordan elimination. It's more sophisticated algorithm. Discover que this equation disappear. Wow. Why? Because it's a zero. It's nothing. I create intentional. Look at that. What happened equation number 2 and number 3. Look at that. Pay attention. It's a little bit, in this case, not too hard. But in another case, super hard. Discover this. This equation and this equation is the same, guys. If you multiply by -1, the equation number 2, you get the equation number 3. Because 0 have no sign. So these equations are dependent. An elimination process discover this fact. These disappear. It's because one equation is depending of the another equation. It's the same plane in this case. And we can focus it in the identity matrix. Dimension. So you delete this equation. Don't participate in the game anymore. No, delete. Entonces es obvio que the solution is x equal 13 over 9. Y is equal 7 over 18. And C is equal 19 over 18. End of story. One solution, unique solution. We discover elimination process magic. Discover that one equation is depending, and that's it. One solution. In this case, another case, you see surprise now. Let's move on to example 5. Example 5. Example 5. May I erase the board or not yet? Okay, erase the board. Example 5. Example 5.
You're still in matrix, sir.
Huh? What
You're still in matrix.
Okay, you want to see again the matrix?
No, you're still in matrix. I don't see the board.
Wow. Okay. Understand. Example 5. Example 5 is a little bit confusing. It's -4x plus y equal 5. Equation 2x minus y plus c minus w, wow, equal 5. Equation 2. And c plus w equal 4. Equation 3. Okay, entonces classification. Determine, underdetermined, overdetermined. Classification.
Underdetermined. Under.
Es obvio que under. Entonces never in this system we have solution. Because in this example, each equation represent, this equation leading in the 4-dimension, right? Space, because it's X, Y, Z, W. 4-dimension space is impossible to represent geometrically. It's the 4th-dimension of the Einstein. Okay, we have 4 dimensions, okay, it's X, Y, and Z, the classical dimension of the space, and the time is another extra dimension. But okay, it's possible, yeah, it's possible to represent, but it's very, very hard, confusing. Now, for us, it's not important the geometric representation. This is each equation represents no plane, it's hyperplane. Okay, it's another definition higher than the plane. It's a plane que live in the 4-dimension space. Okay. I don't care. Geometry is complicated in this case. I don't care. I represent in matrix form. And matrix form is -4. This is the X. Let me organize perfectly. CW, line, right hand side. 4, 1, no Z, no W, and 5. This is my first equation. My second equation is 2, -1, 1, -1, 5. Is it coincidence? 5? Yeah, 5. And the last equation, no X, no Y, missing 1, 1, and 4. Okay, this matrix is 3 by something. 1, 2, 3, 4, 5. 3 by 5. Okay, this is my matrix. I put in the GeoGebra. Let me go. Okay, here we go. We'll space for the next example. The next example is -4. -4. See, I make a mistake, you help me. -4.
1005.
005. 1,
005.
0, 0, 5. Super
Second
good.
one is 2, -1.
Wait for me. 2,
Yes, sir.
next.
-1.
-1. Go ahead.
1.
1 and
-1.
-1 and
5.
5. This is my second equation.
And then the third one,
last equation is
0, 0,
0,
114.
114. Okay. This is my system, right?
Yes, sir.
I select this number, I create the matrix with this number. And the GeoGebra call matrix M5. Okay, entonces you click in input of the cast. If you want, guys, you can delete. So it's easy to delete any problem, but I don't want to delete, no? You, for example, you right click here in this icon and you select delete. But no, I don't want. And you put in delete, you put in the input, reduce it of the matrix file, no? Matrix file M5. Press enter, boom, and this is the answer. Wow, what the hell is that? Interpretation this. Interpretation this. I want to copy in the whiteboard. Interpretation this. Interpretation this. Interpretation this. Switching whiteboard. Okay. So you put the arrow. I understand very well what means this arrow. You put R, R, E, F. This is the way you answer in the test this complicated problem. And you copy. And you copy. 1, 0, 0. 1. The line, -3. You copy here. 0, 1, 0, 4. -7. You copy 0, 0, 0, 0, 1, 1. And 4. 3 by 5 again. 3 row, 5 column. Now I want to interpretation this. Okay, I can see, wow, look, this column is the column of the X. This is the column of the Y. This is the column for the Z. And this is the column for the W. Then, in the column X, Y, and Z, I see the famous identity matrix of the dimension 3. That means that the variable X, Y, and Z are non-free. The only que contain numbers, real numbers, is W. That means que W is the free variable. And when you have free variable, automatically you understand that we have infinity many solutions. So infinity many solutions, you express it, the three equations, like a function of the free variable, because W I know is already a number. Okay, so you express it, for example, the first equation. Okay, let me try to do fast because it's too easy. The first equation is X plus W equal minus 3. In conclusion, you isolate X is equal minus 3 minus W. Because I move W to the other side. Yes or no? You follow me? Remember, this line indicates equal sign. It's the line that separates left and right hand side of the equation. You move this W to the other side, is positive 1, but you move to the negative. Y is equal minus 7 minus W. Yeah, because of 4W. Look 4W. And finally, Z is equal 4 positive minus W. Because it's W, 1W, bring to the other side like a minus. Okay, entonces, what is the answer I need to see in the test? When you write like that, solution set is equal. My solution living in the Einstein space, que es X, Y, Z, W. Suppose que W es in the Einstein space time. Si es time, no es no W, es T, pero I don't care. It's a physics. Such that X is equal minus 3 minus W, comma, Y is equal minus 7 minus 4W, comma, C is equal 4 minus W, comma, and W is all real number because it's free. And W is all real. Close the curly bracket, and this is the solution set. I suppose this is the line. How do you know it's the line? Because when you have one free variable, it's a line. One free variable represents one dimension. And one dimension object in geometry is a line. But this line living in the Einstein space, the four dimension, I can know. I don't know exactly what is that. No, it's very complicated to express geometry. Any question? Any question? Any question? Okay. One more example. One more example. Number 5, number 6, no? Yeah, number 6 is one more example. Let me try one more example. Number 6. We have time. Yeah, we have time. Okay, good. Very good. Guy, you are the best. I suppose the student here with me today is the student who want to pass this class. The rest, no. Okay? Yeah, absolutely. Any test, I realize very well the class is split in two pieces. The good student, you, 5, A plus, and the super bad student, it may be C or maybe D or maybe F. Okay? Okay, entonces this is the student que want to pass. The other student left in one moment, I don't know, it's too heavy, it's too complicated. Too complicated this part? Too complicated? It's complicated or no? No, it's not complicated. Wow. Okay, let me go to example 6. Example 6. A little bit, you have to practice, coño. Okay, so you have to practice. Okay, example 6. Example 6 is 2x plus minus 2y minus again 2z equal to equation 1. 2x plus 3y plus C equal to equation 2. And 3x plus 2y equals 0. It's weird, this example. This example is classification. Determining, under determining, or over determine. Over, under, or no, or determine.
Under.
Under. Because how many equations we have? How many equations?
3.
3 equations. How many unknown we have?
3.
Entonces, it's the same number, right?
Okay, you're right.
Yeah. No. No always I am right. Entonces, es obvio que es determined. And determined, we expect everything. Maybe one solution, infinity many solution, or no solution. Now, surprise, in this example I create for you. Use present matrix language, 2 minus 2 minus 2, and 2. This is x, this is y, this is z. This is 2, this is 3, this is 1, this is 2. Right hand side now. This is 3, this is 2, this is 0. No C, the last equation. And 0. It is make this 3 by 4. Okay, super. I put in GeoGebra now.
Professor, I have a question for you.
Yes,
You always line up the rows 3 by 4. That's just not to get lost, just as a reference point, or because I don't see no input. We don't ever put input on it. Just wondering.
No. Okay, the habit to put the dimension is because in another software, in another software, it's mandatory when you go
Okay.
when you go inside to the matrix editor, you need to specify. And guys, there are several, not necessarily GeoGebra. We have GeoGebra in the smartphone, and we have another application of the matrix for the smartphone, iPhone or Android. So either way, guys, we're using exactly the same function. Reduce the row echelon 4. Reduce the row echelon 4. So I recommend GeoGebra because GeoGebra is free. GeoGebra is online in the cloud. You can save your information after that, but not necessarily GeoGebra. There are another software, but on the other software, you need to specification the dimension first. Because when you have specification 3 by 4, automatically the software reserve for you 12 position. And you put inside the position 2, negative 2, negative 2, 2, 2, 3, 1, 2, blah, blah, blah. Okay? Okay, let's go to the GeoGebra now. GeoGebra now. Boom. Okay, look at that. Okay, there you go. GeoGebra, to space for the new example is 2, 2, negative 2. What is the student can help me in this job? Because it's complicated for me.
2, negative 2, 2, and 2.
Wait. 2, negative 2, and negative 2 again, or 2?
No, 2, 2.
2, are you sure?
Yes, sir.
No, it's negative 2, 2.
Oh.
Then I wrote it wrong. It goes 2, negative 2, 2, 2. Sorry.
Okay. No, it's okay. We are doing together, no? 2, 3, 1, no? 2. Okay. 3, 2.
3, 2, 0.
No, 32, no. 3, 2.
3, 2, 0, 0.
0. Wow. That's it, right? That's
Yes,
it.
that's it. Now you do the matrix,
Let
right?
me create the matrix. Okay, boom. I have my matrix here in algebra. In algebra window. Because in input, you put capital R-E-D. I know I put it completely wrong. But the GeoGebra understand very well everything. Okay, it's R-E-D. Okay, good. Of the matrix is M6, no? Present. Boom. Wow. What the hell is that? Interpretation this. I want to copy this answer in the board because I want to interpretation this. Interpretation this. Interpretation this. Wow. 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 Do you see the board? No, not yet, no? Okay, wait a second. Okay, switching. Yes, the board now. Okay, close and close. No. You see the board now? Yes or no?
Now we see it. We see it, sir.
No?
Yes.
Yes?
Yes, sir.
Okay. After the application of the function RREF, we get this matrix. Look at that. 1, 0, minus 2 over 5. This line, 0, 1, 3, 5, 0, and 0, no? And the last is 0, 0, 0, 1. I try to interpretation. Let me make it soon to interpretation this answer. What do you think? We have one solution, infinitely many solution, or no solution? Help me, guys, to understand this complicated problem.
No solution.
No solution. Very
No
good.
solution.
Very well. Because I can see a contradiction. Look, this is, remember, I recall, this is X column, Y column, C column, right-hand side column. You can see in the last column, look at that, this is the most important moment, crucial. We can see contradiction. Because the 0x plus 0y plus 0c equal 1. And 0 something is 0. Is 0 equal 1 is completely false. This is a contradiction, therefore no solution. Entonces, always is the same. It's super easy to identification no solution because you see in the last row.
The hardest part for me right now, Professor, is actually this, interpreting it at the very end from where we get the graph. It's kind of hard to look at it. Is there any pointers?
Let me spend the time. The rest of the time, we have 5 minutes. I want to explain, to summarize everything that we covered today. Pero super contraction of the information. Let me show you. Don't worry, be happy. Be happy because you need to understand very well that part. Okay, suppose we have 3 scenarios. Scenario number 1, after the application RREF, suppose that we got this possibility. 1 0 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 5 4 6 7. Right hand side. How many solutions we have in this case? How many solutions?
4 solutions, sir.
4 solutions. Wow, no.
One solution.
One solution. Well, yeah. Maybe maybe he is right. One solution, but one solution que corresponde with the tuplet 5, 4, 6, 7. No, the X is 5, Y is 4, C is 6, and W. No, see, I assume some people call the variable no XY, X1, X2, X3, X4. Suppose we have 25 equations. You call X, Y, Z. No. We have only 26 letters. Suppose we have 100 equations. So X1, X2, X3 is the best way to call. So a typical one solution. So in 4-dimensional space, Einstein space, this hyperplane is intersecting from only 1 point. 1 point. Okay, so how do you know that? Because you can see clear here, wow, it's the identity matrix of the dimension 4. This is I4.
Is it good, Professor, quick question, is it a good way since everybody has at least one, never mind, one second.
Yes, okay. This
never mind, the kids.
no, my own word, this is you can see you got identity matrix. Remember, identity matrix is one special matrix, que the main diagonal is 1. I don't know, identity, the rest is 0. Suppose that we have 101. This is identity matrix 100. You recognize like that. You will be able to recognize case identity matrix, and the rest we have no free variable. We have no free variable. Do you understand that we have no free variable? Okay, I want to complicate your life now. Look at that. Suppose this example. I don't know where I come from. 1 0 0 0 0 1 0 0 0 0 1 0 0 0. Bueno, no 0, no 0. Sorry. Bueno, why not? 0 0 0 1 5 6 7 8 9 10 11 12, and this is the right hand side. What do you think? We have infinity many solution or one solution?
Infinity many solutions.
Infinity many solution, because
Infinity
you can
many
see,
solutions.
wow, you can see here, clear like water, the identity matrix of the dimension 4. This is I4. Therefore, x1, x2, x3, and x4 are non-free variables, but x5 is free. It's the only free. Okay? Down the right-hand side. So you write. How you write? You write equation by equation. Suppose the first equation is x1 plus 5, x5, it's a coincidence, 5 equal 9. And you isolate the non-free variable. So x1 is equal 9 minus 5x to the 5th power. And one by one like that. x2, do you understand this or no?
Yes, sir.
Eso. You isolate x1, x2, x3, x4, one by one row, and you express it, the non-free variable, like a function of the free, no? Okay, another example gets confusing, very confusing. Look, suppose this. Suppose 1 0 0 1 0 0 0 0 2 3 4 5 0 0 0 0. In the right hand side we have 7 8 9 and 10. No, 10 no, and 0. No, 0 here, sorry. Wow, what is that? I don't understand this part. Let me erase this. 7 8 0 0. Interpretation this. Suppose I put a system in the test. I like so much to put this example in the test. You can see in the review back and forth. What happened in equation, we have row 1, row 2, row 3, and row 4. What happened with row 3 and row 4? What happened? What's going on?
They're all
They're all
zeros.
zeros. They're all zeros.
Okay, I understand that, but what means that?
No solution.
No solution, no. Means
No, not solution. Undefined.
No, undefined. That means when you see one entire equation, one entire, was depending equation. So this equation, elimination process, the software, your Jira, discovered, wow, the equation 3 and the equation 1 is useless. It's depending for the rest.
Okay.
So you can delete mentally if you want. You rewrite again the system.
It doesn't matter.
It doesn't matter. It doesn't matter. And now, and you focus it on the rest of the story. And the rest of the story is I can see here identity matrix, yes or no? But the dimension 2. And we have 2 extra columns. Okay, I suppose que S1, X2, X3, X4, and right hand side, no? So we have the variable X1 and X2 associated with the identity matrix is non-free. And this is free. In this case, we have two free. Wow, we have two free. And when you have two free, I suppose that the solution object is no line, it's a plane. But entonces you are doing exactly the same. You will solve for x1, and you say in the first equation, x1 is 7 minus 2 x3 minus 3 x4. Do you understand this? Okay, I bring 2 and 3 to the right hand side, no? And x2, okay, another non-free variable, is equal 8 minus 4 x3 and minus 5 x4. Do you understand this equation? Yes or no?
Yes, you're getting it from the top. You're getting the x value from the top, not from the other, like it would be x, y, z, w. Now you're getting it from x3 and x4.
In general, x1, x2. Okay. And what about x3 and x4?
Zero.
No.
Zero? No?
No. No, zero. So when you write solution set is the x1, x2, x3, x4, such that something, you copy this equation here, comma, you copy this equation here, comma, and x3 and x4 are free variable, que es sinónimo to say en coloquial. Bueno, free es colloquial language. En strictly mathematical language or real. Do you understand? That means, guys, que x3 and x4, the domain of this guy is all real number. No restriction. Got it? Clear? Okay, so the next time is amazing, because the next time I want to discuss in another completely different way to express the, o sea, we discussing in this chapter 3 different approaches to solving the linear system of equations using matrices. The first one that we studied was reduce the row echelon, but this is not the only one. Okay? Okay, bye. Time is over. Super.
Thank you, Professor. You have a great day, sir. Thank you.
Mandy Angulo is there or no? Mandy Angulo is there in the classroom. Mandy Angulo, no?
I don't know.
No. I asked you. See, Mandy Angulo is here. I am here.
I'm here.
Okay.
Sir,
Mandy?
no, this isn't Manny. This is Joyce.
It's Joyce. Okay, Joyce.
Did I get the partial fraction right?
Bueno, okay, why no? Bring me.
No, I sent it to you.
I don't see.
I sent it to you on Monday night.
Oh.
I mean, I sent it to you on Tuesday night.
Okay. The problem is that you are excellent student. Then when I see the test, I don't see the rest. I suppose that, well, okay, like,
okay, well, I sent it to you Tuesday because I wanted to get that extra 10. I'll send it to you again.
I try to, please, I appreciate it so much.
I think I got it right, so I want to make sure.
Super.
Okay, thank you.
Pleasure. Bye-bye. Take care.
Bye.
Professor?